Hey everyone, it's Chloe from the Arizona Science Center, and today we're going to be talking about thin films. So we're going to be making a cool bookmark like this one that says I love science, and we're also going to be reading Bees, Snails, and Peacock Tails by Betsy, Franco, and Steve Jenkins. In the day and in the night, on the land and in flight, tucked in hollows of trees, in the tide pools and seas, you'll find patterns and shapes from the snakes to the bees. Study a beehive and you will see the mathematical genius of the bee. The hexagons you'll find inside fit side by side by side by side. This math is passed mysteriously from worker bee to worker bee. Moths show their symmetry every spring, flitting at night on fragile wings. Notice the colors and stunning eyes perfectly matched on either side. And attracted to windows or candlelight, moths are kaleidoscope shapes in flight. Do you see its eyes on its wings? The fact that they're the same on both sides is what we call bilateral symmetry. Some spiders weave delicate tapestries that shine in the sunlight and sway in the breeze. They spin lacy lines, then go round and round. Their knowledge of shapes is truly profound. They sit in the center, admiring their art, and wait for those flies who aren't quite as smart. What happens when flies fly into the spider web? Do you know? They get stuck. It's a little sticky. If you should meet a peacock pair, the male's the one with all the flair. The female, who is rather plain, is dazzled by his patterned train. She watches as he struts and preens, his fan ablaze of blues and greens. So I have a little peacock feather here that we can take a look at when we're done with the book. Look up in the sky, and seasonally you'll notice it's filled with graceful. A knowledge of angles helps migrating birds to fly with less effort and also be heard. By forming a wedge, the swans and the geese slice through the air and travel in peace. The snake rubs its nose on a branch or a rock, then takes off its skin like a knee-high sock. Off comes the old skin, and waiting below, repeating designs appear in a row. Sea stars have 5 arms, or 6 arms or more, with sensors called eye spots that help them explore. They can grow back an arm if they get into scrapes, for they take such great pride in their bright, starry shapes. The animal known as the pufferfish does not want to be someone's gourmet dish. Whenever it senses there's something to fear, it puffs itself up till it's almost a sphere. Can you do that when you get scared? Do you go? I don't. Oh, I might have to turn the book for this one. The beautiful spirals on top shell snails are miniature castles with tiny details. The spirals go round, getting wider and wider till you get to the snail, the shell's inside her. That one almost made me dizzy. So there you have it. I think you'll agree that creatures on land, in the air, in the sea, make patterns and shapes naturally. And at the very end of the book, there's all different kinds of animals that we saw inside of it. So that was really fun, and remember we talked a little bit about the peacock feather. So when you look at a peacock feather, do you see how it kind of shines in the light, and as you move it, the light almost shifts, right? It doesn't always stay green, it kind of goes green, then a little bit yellow, then a little bit blue, right? So why do you think it does that? Now that's actually because of what we're going to learn about today, which is thin films. So thin films are going to be exactly as the name describes, a very thin film, a thin layer. And that thin layer, in the case of the peacock feathers and in case of the bookmark that we're going to make today, it's shifting the light. It's absorbing that light. It's making it do all different kinds of things that we don't normally see. So the light that comes from the sun, we know from science and from rainbows that when the light is being separated, it's a whole bunch of different colors, right? It's not white like we tend to think. It's all of those beautiful shifting colors of the rainbow. So today I have some water in a tray. I gotta be careful not to spill it. And I'm going to be putting some of clear nail polish on top of it. And then I'm going to slip my black piece of paper. It's just a regular black piece of paper. I just cut it in half. And you're going to slip it underneath and lift off that layer of nail polish. And the nail polish is going to be a very thin film that's going to shift the light. Now, thin films are also going to be in things like solar panels. Those have thin films on them, and those thin films are going to be pulling the light into different directions. So I'm going to put some clear nail polish onto the surface of the water. I just did a couple drops, and I can already see some of that nail polish spreading out and separating the light. So now I'm going to take my black piece of paper, I'm going to slip it underneath and lift it up. Oh, there's kind of a lot of nail polish on mine, but you can kind of see that, right? It's pulling that thin film that's now covering, there we go, I just pulled it off. That's now covering my bookmark. Can you see that rainbow shine? That's the thin film. That's the thing that's creating those shifting colors, and we just created a thin film bookmark. So again, all you need at home is going to be just a little tray. You need some clear nail polish, and you do a similar method to what people call like water marbling, right? But instead of dipping it into the water, you're going to slip it underneath the film and gently lift it up. And that's how you're going to get a nice, cool, shifting light that represents our thin films. Well, thank you so much for watching our Early Learning Live today. We do this every morning at 9:30, and you can check us out every day, Mondays through Saturdays at 9:30 a.m. for the Early Learning Lives. And then we do also have our 1 p.m. demonstrations, and today it's actually going to be about zoetropes. So we'll see you then. Have a great rest of your day.